Hi! In this lesson, you will learn how to solve the problem of organizing children into groups more efficiently. More specifically, we will come up with a polynomial time algorithm for this problem, as opposed to the exponential time algorithm from the previous lesson. But in order to do this, we first need to do a very important thing that you should probably do every time before solving an algorithmic problem. You should reformulate it in mathematical terms. For example, in this problem, we will consider points on a line instead of children. For example, if we have a child of age 3.5 years, we will instead consider a point on the line with coordinate 3.5. And if we have another child of age 6, we will instead consider a point with coordinate 6 on the line. Now, what the groups of children correspond to? If we have a group of children, it consists of several children, and several points on the line correspond to this group. And the fact that the age of any two children in the group differs by at most 1 means that there exists a segment of length 1 on this line that contains all those points. Now, the goal becomes to select the minimum possible number of segments of length 1 such that those segments cover all the points. Then, if we have such segments, we can just take all the points from that segment in the same group, and any two children in the group will differ by at most 1 year. Now, let's look at an example. So we have a line with a few points on it, and we want to cover all the points with segments of length 1. Here is one example of such covering. All the segments on the picture are of the same length, and we consider that this is length 1 of this line. This is not the optimal solution because below there is another example of covering, and we have only three segments, and they still cover all the points. Now we want to find a way to find the minimum possible number of segments to cover all the points in any configuration. We want to do that using greedy algorithm. And you probably remember from the previous lessons that to come up with a greedy algorithm, you need to do a greedy choice and to prove that this greedy choice is a safe move. I state that in this problem, safe move is to cover the leftmost point with a segment of length 1 which starts or has left end in this point. To prove that this is really a safe move, we need to prove that there exists an optimal solution with the minimum possible number of unit length segments such that one of the segments has its left end in the leftmost point. Let's prove that. To do that, let's consider any optimal solution of a given problem with the given points. Let's consider the leftmost point, colored in green. It is covered by some segment, colored in red. Now, let's move this red segment to the right until its left end is in this leftmost point. I state that we didn't miss any of the points in the process because this green point is the leftmost point, so there are no points to the left from it, and while we were moving the segment to the right, we didn't miss any of the points. It means that what we have now is still a correct covering, because all the points are still covered, and the number of segments in this covering is the same as in some optimal solution from which we started. And that means that it is also an optimal covering. So, we have just found an optimal solution in which there is a segment which starts in the leftmost point. So, we proved that covering the leftmost point with the segment which starts in it is a safe move. Now that we have a safe move, let's consider what happens after it. We have the leftmost point covered, and also maybe some other points covered, so we don't need to consider these points anymore. We're not interested in them, and we need to cover all the other points with the minimum possible number of unit length segments. So this is the same kind of problem that which we started with. So this is a sub-problem. Basically, it means that we have a greedy algorithm. First, make a safe move, add a segment to the solution with the left end starting in the leftmost point, then remove all the points which are already covered by this segment from the set, and if there are still points left, repeat the process. And repeat this process until there are no points left in the set.